Today I wanted to show you a new tool that we've made available to our customers on our website, www.pdblowers.com. It's a blower selection tool, and it can be found in a couple different spots on our homepage. Right here where I'm showing with my cursor, we have blower selection where it takes you to a shortcut. If you scroll down the page and you go to our resource center, we have the blower selection down there as well, so there's a couple of spots that you can get to it. So if we click blower selection, we come to our PD analysis long form selection form. We also have a quick selection version where you don't put in all the parameters if you just want a really fast selection, typically on air. But today we're going to focus on the long form selection. The first block that you see here, we title it pressure. So you can select pressure or vacuum. And if you have a vacuum application where you're looking to pull a vacuum on a process, whether it's pneumatic conveying or process vacuum of some sort, you can click the radio button for vacuum. If you pick pressure, we're assuming that you've essentially got an atmospheric inlet and you're going to be discharging at some pressure above atmospheric pressure. We have a couple of blocks here, an inlet pressure drop block and a discharge pressure drop block. I just wanted to show you quickly, we have several different units of measure that you can use here depending on how you want to specify your inlet pressure drops. Inlet pressure drops are typically going to be associated with your inlet filter and inlet silencer. Your discharge pressure drop will typically be affiliated with your discharge silencer, fittings, relief valve, check valve, that sort of thing. Traditionally, we use about a 0.3 psi pressure drop for the suction and a 0.2 psi pressure drop for the discharge. The next block shows flow. We have a radio button that shows actual flow, or you can select standard flow, or you can select mass flow. So depending on how you're calculating your performance, you have several different options. So in this case, let's just put in 100 CFM for actual flow. Now, an important feature I want to point out to you is that the standard flow changes as you modify this. Let's say you put in 200 CFM. It will then show you the SCFM value and a mass flow value for that 200 CFM. If you happen to select standard flow, you can put in 200, and then you can see what the actual flow is for 200 SCFM. Now, standard flow is based on standard set of conditions, which we actually have a block that allows you to change those standards if you're working with a different standard. For the United States, our typical standard is 14.7 psia, 36% relative humidity, and 68 degrees Fahrenheit. So we're going to just leave those unchanged for the moment, and you can see how that impacts your actual flow versus your standard flow. The other thing that impacts those flow calculations are your process conditions. So these calculations automatically take into account the elevation. In this case, our default elevation is 500 feet. You can change that based on your actual site conditions. For instance, I put in 1,000. You can see that my ambient pressure now changed to 14.17. I put in 0. If you're along the coast or at sea level, you're at 14.7. So this gives you a great tool to put in your actual site elevations to see exactly where you're going to be typically for that location. So I'm going to go ahead and put my 500 CFM back in. You can also click the ambient pressure radio button and put in whatever ambient pressure you want. So I like to use the elevation button. It just makes things easier if you know your site elevation. On ambient temperature, I put in a default value of 100. That's a pretty typical maximum default that we put in. If somebody's saying, well, give me a calculation for worst case conditions, that in most cases is the worst case. Some places you'll see higher temperature conditions and you can make changes based on those requirements. Over here, you've got inlet temperature. So let's say, for instance, your inlet temperature is not directly coming from atmosphere, but some other process. So if that deviates from your ambient temperature, you can put that in at this block here. System discharge pressure, I'm going to assume 5 psig. Again, kind of focusing on the units of measure, we give you a variety of units of measure if you don't want to use that particular unit of measure. But typically we're using pounds per square inch gauge, so that's a good unit of measure for us. Relative humidity, I'm going to assume 80%. So 80% relative humidity at a 100-degree day, mighty hot. But that's typically a fairly common worst-case scenario that you might see. So you've got a radio button here that shows open system or closed system. So closed system, you can see that now you can adjust your blower inlet pressure. So let's say you have a sub-atmospheric pressure because of some process variable, or perhaps you have a hyper-atmospheric pressure because of some process situation. So this allows you to make that change in this block. In my case, I'm going to assume an open system because 90% of our systems are open to atmosphere. Then we have an optional blower selection criteria. Basically, what this allows you to do is set filters for different parameters on blower selection criteria. I'm going to handle this in a separate tutorial, so I just wanted to kind of highlight it that it's there and available if you want to set filters on what blowers are selected. We already discussed standard conditions. Brings you down to models to select. So the default models to select are our most common units, the UREI, RAM, RCS, RCS-Js, those various units. If you wanted to add additional options, the Roots Flow machine or the Roots RAM-X tri-load machine, if we're doing a higher vacuum application, the Roots DBJ, you can select those boxes as well. But in most cases, most operating parameters that we're going to be dealing with, the first checkbox will hit most of our performance requirements. So we get down to the blower chart. We can hit select blowers and it gives us a blower selection. Now I've got a sorting tool here, sort output by price. So the lowest price is at the top and the highest priced unit is at the bottom. You can also filter by horsepower, or sort by horsepower. It will give you the lowest horsepower going up to the highest horsepower. And likewise noise, lowest noise to highest noise. So this gives you some flexibility in filtering the units in a way that makes most sense for your particular need. Most of our customers like to filter by price. You want to get the most cost-effective unit for the performance parameters that you have, so that's a good criteria to make your selection by. You can select different units by just clicking on that particular line, and where that becomes important is down here at the schematic. So based on whichever unit you select, the process conditions change in these blocks. So here we represent 231 ICFM at 14.43 and 100 degrees Fahrenheit. So those are your inlet conditions. We've got a 0.3 psi pressure drop that we put in at the top. So at the blower suction point itself, it's at 14.13. At the blower discharge flange, it's 5.2. And the actual silencer discharge is 5. And as you recall up here, we specified a 0.2 psi pressure drop, so that illustrates the pressure drop between the blower discharge and any of those vessels that are between blower discharge and your process. If you want to preview the performance summary, you can click Preview Performance Summary, and give you a nice display of all of the different operating parameters for that particular application. You can print that to a PDF, you can print it on your printer, save it to a file, whatever your preference is. The information is all there and available. You go down in the blower performance area and you can see we give you the horsepower, we give you the discharge temperature, the estimated noise level, the discharge volume, bearing life for either V-belt or coupling drive, gear tip speed, and the connection size. So some handy information to have. We also provide a tool for generating a performance curve. The radio button here is selected for single performance curve at actual operating conditions or operating pressure. So you can hit a preview button there and it will generate a performance curve for a range of speeds at your actual operating conditions. So for instance, in our particular case, we've got a differential pressure of 5.5 psi. So this curve is specifically for 5.5 psi at blower speed versus blower power, blower speed versus temperature rise, and blower speed versus actual flow. So those are handy if you just want a quick reference at where all the different parameters are going to fall. We also have the ability to do multiple curves, and we can do a multiple curve here generated at standard conditions. And again, we start from 1 psi here to 7 different color codes. You can see based on how fast you turn the unit what the respective horsepower is going to be at a given pressure rise, what the temperature rise is expected at various operating conditions, and what the actual flow would be at these various operating conditions. So it gives you a wealth of information that you can keep associated with your blower so that you know what your limitations are. That concludes our tutorial on our long form selection tool. If you have any questions, please feel free to email us at sales@pdblowers.com, or you can click the contact button. You can come here to contact us, put in your name and information, any comments that you might have. You can attach some files if you have some files, and we'll be glad to get back to you with some answers. Thanks for your time.